Okay. Good morning, everyone. My name is Asier, Urueña, from Spain. I work at TECNALIA, a research center. We have 400 people working on everything doing with digitalizing construction. And I focus on applying AI to different use cases. So it was great that you pair us, the speaker from before, Bayu and I, because it's the same use case, Scan-to-BIM, but with another approach. So the motivation is the same. It has some differences. So what we have, I'm going to leave this image a bit so you can, because it's this use case. Instead, the problem with traditional Scan-to-BIM technologies is that you capture the whole point cloud, go to the office, and then segment it. Okay, so sometimes maybe you have to come back and take some more captures because you left something behind. And also the processing time in the office. So we want to tackle those issues. So we are segmenting in real time with a portable device. So when inside or on site, we can review the result and have the 3D assets already segmented individually. Okay. Yeah. So this is what I just said. You can reduce costs, reducing the visits to the site, and yeah, less processing time. We are focusing because we are using a portable device. In this case, a headset. We want the target to fit in the frame when the person is doing the walkthrough. So we are focusing on small MAB or similar assets. Okay. Well, this is the detailed methodology, but we can see the simplified one. We'll first train, fine-tune a YOLO model. In this case, we used V7 because at the time we were starting the first part of the research. We selected this one, but we should update it. Okay. And the other part, so the training part or the fine-tuning part is before going to the site. It's done once for each one of the classes you want to detect. And then comes the real time, which is the capture, identification, and reconstruction. And so the capturing the capturing process will be, in our case, we've selected a HoloLens device, but we could have selected a mobile phone or a similar one. We selected the HoloLens because we had a Python, it has a Python SDK ready, so it was easy to attack the different streaming of the different sensors. And also it already calibrates the depth information with the image information in real time. So it's easier you gain some steps there. The identification part, so in real time, the person is walking through the site and the model, the YOLO model, is identifying all the different trained elements. And a last reconstruction phase. This one is done with is done on site, just when you turn up the identification for one of the targets. And it takes a little longer, like 3-4 minutes, and it consists mainly of a cleaning step. We apply a DB scan clustering method to clean background noise and just get the first cluster, which is normally the main object you were trying to capture in the first place. Okay. So going a bit in detail, we gathered 500 custom images, and we focused on switches and plugs, okay, which are two similar targets. And with our images, it was not enough, so we updated with 6,000 raw flow samples we found. about the same targets, and also did some augmentation. Okay. Oh, and we are using the bounding box mode of the model. Okay, this is for the device, the HoloLens. The HoloLens detects with different sensors. We are using the sensor of the real image, the color image, okay, so RGB, and the depth sensor, one of the depth sensors, which adds the depth for the same image, and it synchronizes both matrices. Okay. For the YOLO model, you all know, okay, the V7, but we should update. We had already good numbers. And for the reconstruction or cleaning part, you can see on the right side, the objective is to target one single element for this proof of concept. Okay, we could not clean and do multi-class because we are already detecting everything in the image, segmented it. But for the proof of concept, we wanted to simplify and just get the first cluster, discard the others because they will be mostly occluded for the first one. Well, that's another possibility to enhance this part. Okay, and for the experiment and gathering some numerical results, we're comparing a regular power strip and a keyboard. The keyboard is not using the fine-tune model because it's already in the out-of-the-box YOLO models. Okay. So the main there are several indicators of roughness, normal consistency, density, background noise. So the main indicator is the time it takes, which is very consistently low for our method. Photogrammetry has, when in the keyboard instance, performs a little better, but then in the power strip, it goes up to nearly an hour, so it's not consistent. The laser method is consistent, but it takes longer. Okay. And well, for the bad indicator and normal consistency in our method is due to the HoloLens sensors that don't have that kind of precision. But we think that for capturing a 3D asset to complete in a BIM is enough. Okay. And you don't have both of the other methods. You require off-site processing. With our method, you review it in real time, the quality of the visual quality, at least, of what you're getting. We did some extra tests that we didn't evaluate with the numbers. Okay, but you can see in the keyboard, you can see a lot of background noise. That's mainly because of the form factor and that it's not mounted on a wall. Because if it was mounted on a wall, the bounding box would be perfectly or almost perfectly aligned with the shape, and we wouldn't get so many backgrounds. So that's a limitation. And concluding, well, some of the strengths we think that this has is a modular process. You can change the device, you can change the computer vision model. Of course, we don't need so much post-processing time, and you don't need to come back to the site or avoid as much as possible that. And you can use cheap devices to do the capture, okay? Or at least cheaper setups than the traditional ones. Limitations, we're just targeting small MEP assets. We should make a better data set for sure. There's some sensitivity to lighting changes, okay? And we didn't do the full conversion to BIM, which would be another interesting step. And for me, the main or the most impactful one would be to elevate this to multi-class, because we already are detecting in real time every class in the image. So it's just adjusting a little the workflow to keep all these classes at the same time and reduce and not going one by one, which is the current state. So, okay, that will be all.